Dear students of plus 2, medical and non-medical, respected parents, respected teachers. So, first of all, welcome you all on my YouTube channel, Physics Concepts and Motivational Talks. So, in the first video, I have explained the first chapter, electrostatics, the topic electric charge and electrostatic force, that is Coulomb's law and properties of electrostatic force. Today I am going to extend the same topic, Coulomb's law in vector form, which is very, very important. So just spend 10 minutes with me and you will understand this vector form of Coulomb's law, which is very, very important for next applications of Coulomb's law. So let us start Coulomb's law in vector form. Now, what is Coulomb's law? It states that there exists an electrostatic force between two point charges separated by a certain distance, and this force may be attractive or repulsive, and it is directly proportional to the product of the magnitude of two charges inversely proportional to square of the distance between them. And for free space and vacuum, this magnitude of electrostatic force between Q1 and Q2 point charges is given by 1 upon 4 pi epsilon naught Q1 Q2 upon R square, where epsilon naught is known as permittivity of free space. Its value is 8.85 into 10 to the minus 12 SI units. Now, suppose we have 2 point charges Q1 Q2 separated by distance R. Let R12 cap is a unit vector from Q1 to Q2. R21 cap is a unit vector from Q2 to Q1, because unit vector is used to give the direction of a given vector. F12 vector is the force experienced by Q1 due to Q2. F21 is the force experienced by Q2 due to Q1, because this force is mutual and moreover this force is central. It acts on a line joining the two charges. It may be repulsive or attractive. We have taken two charges Q1, Q2 as like charges. So we have shown F12 and F21 in the opposite direction, that is outward, that is force is repulsive in nature. Now, any vector A by definition is given by A cap. That is, any vector A is given by the product of its magnitude and a unit vector in its direction. So similarly, using this relation, we can write F12 vector is equal to F12 vector magnitude and R21 cap. Why R21 cap? Because R21 cap and F12 are in the same direction. So R21 cap gives the direction of F12. So F12 is given by substitute value of this magnitude 1 upon 4 pi epsilon naught Q1 Q2 upon R square, then into R21 cap. So this gives force experienced by Q1 due to Q2 in vector form and in terms of unit vector. So F12 is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square into R21 cap, where R21 cap is the unit vector in the direction of F12. Similarly, we can write F21 1 upon 4 pi epsilon naught Q1 Q2 upon R square, magnitude is same, into R12 cap, because R12 cap and F21 vector are in the same direction, or R21 cap gives the direction of force F21. So therefore, first and second equations give electrostatic force in vector form or Coulomb's law in vector form in terms of unit vectors. Now, if we have to write these equations in terms of displacement vector, displacement vector is vector drawn from one charge to another charge. Let R12 vector is the displacement vector from Q1 to Q2. R21 vector is the displacement vector from Q2 to Q1. Then R12 magnitude is equal to R21 magnitude is equal to R, separation between Q1 and Q2. But directions are different. So therefore, again by using this same definition of unit vector, any vector is given by A cap, or unit vector is given by vector divided by its magnitude. That is, A cap is equal to A vector divided by its magnitude. So therefore, R21 cap will be equal to R21 vector upon R21 mod. or R21 vector upon R, because R21 magnitude is equal to R. So similarly, R12 cap is given by R12 vector upon R, because R12 vector magnitude and R21 vector magnitude is equal to R. Therefore, equation 1 and 2 becomes F12 1 upon 4 pi epsilon naught Q1 Q2. Now instead of R21 cap, we write R21 vector upon R. So R21 vector, and R square is already here, so therefore it will be R cubed. So in terms of displacement vector, what happens, instead of R21 unit vector, we have R21 displacement vector, and in the denominator it is R cubed. So F12 is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square into R21 vector. This is Coulomb's law in vector form in terms of displacement vector, that is vector drawn from one charge to another charge. Similarly, we can write F21 1 upon 4 pi epsilon naught Q1 Q2 upon R cube into R12. So when we have F12, so R21, it is different. So F21 here is R12 vector, because unit vector must be in the direction of the given vector. So and given vector is given by magnitude multiplied by its unit vector. Then we come to, this is first and second equation, Coulomb's law in vector form in terms of unit vector. Third and fourth are the electrostatic forces in vector form in terms of displacement vector. Now, if the charges lie in space, that is, let R1 is the position vector of Q1, R2 is the position vector of Q2, then we can join Q1 Q2 or Q1 Q2. So R21, let R21 vector is the vector drawn from Q2 to Q1. Similarly, R12 vector will be a displacement vector from Q1 to Q2. So it becomes a triangle, and by triangle of vector addition, in +1 we have studied the sum of two sides which are the same order is equal to the closing side. That is, by applying triangle of vector addition in this, so we have R2 vector plus R21 vector is equal to R1 vector. It means R1 is equal to vector is equal to R2 vector plus R21 vector. Simply triangle of vector addition. The two sides which are in the same order, their sum, vector sum must be equal to the closing side. So from here we have R21 vector is equal to R1 minus R2. So we have found R21, that is displacement vector, in terms of position vectors R1 and R2. So similarly, R12 vector is equal to R1 vector minus R2 vector. So if we substitute these values in equation 3 and 4, so we have F12 1 upon 4 pi epsilon same, Q1 Q2 same. Instead of R21, we write R1 minus R2 upon R1 minus R2 mod Q, because separation between Q1 and Q2 is R21, that is R21 mod Q, which is R1 minus R2 mod. Similarly, we can write F21 1 upon 4 pi epsilon naught Q1 Q2 R2 minus R1 upon R2 minus R1 mod Q. So it is very simple and easy to remember. So when we have to find F12, what is F12? F12 is the force experienced by Q1 due to Q2, and F21 is the force experienced by Q2 due to Q1, because this force is mutual. So F12 is equal to 1 upon 4 pi epsilon naught constant, same everywhere. Q1 Q2 means product of point charges, magnitude of point charges. If you have to find force at first Q1, so it will be R1 minus R2. Then जो ऊपर लिखे थले R1 minus R2 mod Q. Similarly, when we have to find F21 1 upon 4 pi epsilon naught Q1 Q2 R2 minus R1 over जो ऊपर लिखा है नीचे R21 R1 mod Q. So it means in general, if we have any point charge Q at position vector R and charge Q dash at position vector R dash, then force experienced by Q due to Q dash F Q dash will be equal to 1 upon 4 pi epsilon naught Q dash upon R minus R dash upon R minus R dash mod Q. That is, if you have to find force on Q, the position vector of Q should come first minus position vector of next charge R minus R dash, and in the denominator R minus R dash mod Q. So it is very easy to remember. So F Q dash equal to 1 upon 4 pi epsilon naught product of magnitude charges, position vector of Q, where we have to find electrostatic force, minus R dash upon R minus R dash mod Q. Now, since R21 cap and R12 cap are opposite, they are unit vectors. R12 cap is equal to minus R21 cap. So therefore, F12 is equal to minus F21. This shows that force is mutual, force is central, and F12 is equal to minus F21 means force obeys Newton's third law of motion. So force may be electrostatic, force may be repulsive or attractive. So these are the characteristics of electrostatic force. I again repeat, electrostatic force is mutual, that is, force applied by Q1 on Q2 is same as that force applied by Q2 on Q1. It is mutual. Second, it is central force because it acts along the line joining the two charges. So it may be repulsive or attractive depending upon the polarity of charges. Like charges repel each other, unlike charges attract each other. And then we come to principle of superposition. Now, means if we, instead of 2-point charges, we have n number of charges, say Q1, Q2, Q3 and so on, Qn, we have n charges at location R1, R2, R3 and so on, Rn. That is, we have to find total electrostatic force due to a number of point charges at a certain point or on the test charge Q. Let Q be the test charge, where we have to find the total, that is resultant force experienced by n point charges on this test charge. So this principle of superposition shows that, or states that, when there are number of point charges, then the resultant force experienced by the test charge due to all the n point charges is equal to the vector sum of the individual forces. So resultant sum of individual forces is the total electrostatic force. So if as the total electrostatic force on the test charge Q experienced by Q1, Q2, Q3 and Qn, all the n charges, then resultant force F will be equal to F1 vector plus F2 vector plus so on plus Fn vector, that is the vector sum of individual forces. This is known as principle of superposition. Now, then applying Coulomb's law vector form. So first F1 is the force experienced by Q1 on Q. It will be 1 upon 4 pi epsilon naught. Product of charges Q1. We have to find force at Q, that is R, position vector R. So QR is the position vector of Q. So at R, then Q1 R minus R1. So we have to find force at R. So R comes first due to Q1. So R1 comes after R. So R minus R1 or R minus R1 mod Q. Simple Coulomb's law vector form. So F1 is given by 1 upon 4 pi epsilon naught Q1 Q2 R minus R1 upon R minus R1 mod Q. Similarly, we can write F2. That is force experienced on Q due to Q1 1 upon 4 pi epsilon naught Q2 R minus R2 upon R minus R2 mod Q, and so on F3, F4. Last, force experienced by Q due to Qn is given by 1 upon 4 pi epsilon naught Qn R minus Rn upon R minus Rn mod Q. So if we combine all these forces, F1 plus F2 plus so on plus Fn. So F comes out to be, so Q upon 4 pi epsilon naught is common. So take common. So first term is Q1 R minus R1 upon R minus R1 mod Q. Second term will be Q2 R minus R2 upon R minus R2 mod Q, and so on. Last term will be Qn R minus Rn upon R minus Rn mod Q. And we make sum of these terms. So F comes out to be Q upon 4 pi epsilon naught summation I is equal to 1 to n in general. If there are n point charges, so summation, you have to add them. I is equal to 1 to n Qi I mean ith charge, you have charge on ith point. R minus Ri the position vector of the ith point charge. So R minus Ri upon R minus Ri mod Q. So in general, total electrostatic force experienced by the test charge Q due to a discrete distribution of charges, that is n point charges, is given by F is equal to Q upon 4 pi epsilon naught, summation I is equal to 1 to n, Qi R minus Ri upon R minus Ri mod Q. This is all about Coulomb's line vector form and principle of superposition. So in the next video, I will discuss dielectric constant and some applications of Coulomb's law. That is electrostatic force due to continuous charge distribution. And that will be the end of this part of electrostatics. So I will cover this electrostatic first part in 3 videos. So very simple. You can just join me for 10-15 minutes every day. You can understand topic, at least 1 or 2 topics daily. So all the best, be happy, enjoy करते फिजिक्स में पढ़ो. Physics is very simple, you can do it, you can do anything, but only thing is you should be positive, you should be happy, you should enjoy when you are learning, when you are studying. So that's all. So all the best, thank you so much, and be happy.